Hi, I'm going to explain to you why the sum formula for the geometric series looks like this. Okay, it is a very small and simple formula, and it seems like a really complicated concept. So I'm going to teach you the trick, or tell you about the trick that they used to make this formula. And we already learned about the trick to make the arithmetic formula, right? Arithmetic series formula. You take that rectangle, or you take that triangle shaped thing and you cut it so that it forms into a rectangle, and then you just find the area for a rectangle. In this case, there's a similar trick, but maybe even more clever. Okay, so to show you how this trick works, I'm using the geometric sequence that you just worked on. You just talked about the guy running 2 kilometers the first day and running 18 days until he finally reached 10 kilometers. So you can see in this graph that for I equals 1, the distance that he ran was 2 kilometers. And for I equals 18, the distance he ran is 10.11 kilometers. And so I'm looking at the blue triangle shape. You can see that the blue triangle shape rises slightly more at the end than it does at the beginning. It's a curve. It's not a triangular-like shape like we saw with the arithmetic sequence. It's one that kind of curves up. Okay, and I drew a representation of that blue curved shape here on the right. Okay, so do you see how it's kind of curved up like that one? I named it S18 because it's the sum of the first 18 terms to get to find out how far he ran in those shoes. And I see that I forgot to write a 1 here, so let me write the 1 here. As you know from your investigation, the on the 18th day, he ran 10.11 kilometers, so that's right there. So on the 18th day, he ran 10.11 kilometers. He ran for 18 days. And what we're interested in is a simple way to figure out how far he ran on all 18 days together. If we could figure out the area of this triangular shape, we could do that. And I'm going to teach you how to use a trick to do that. Okay? The trick is basically this. If we create another shape, which is the red shape that's behind the blue shape, and what is the characteristic of this red shape? It looks exactly like the blue shape, except it has one extra day. It has the 19th day also. Okay? And so the 19th day, you can see, sticks out from behind the 18th day, and it rises up to a height of 11.12. Okay, so we on purpose figured out how far he would run on the 11th day or on the 19th day just so that we could use this trick. And so you don't have to understand why we did that, but it's important for the trick. You'll see why later. Okay, so we have a red triangular shape that's slightly larger than the blue triangular shape, and you can see that if you put the blue triangular shape to the left of the red triangular shape, it fits perfectly on top. So you can see that the area of the blue triangular shape is pretty close to the area of the red triangular shape. The only difference is that the red triangular shape has one extra bar over I equals 19, right? So you can see that you could kind of figure out the area from one or the other, okay? And so I'm going to draw that here. On the right, you see that I've drawn a representation of that. The blue triangular shape is covering the left side of the red triangular shape, and there's a little piece sticking out, okay? Now, to complete the trick, what we need to know is if we take the blue triangular shape, which starts out at distance 2, and the next distance is 2.2, and the next distance is 2.42, if we multiply all these bars by 1.1, what's going to happen is each one of these bars is going to get 10% higher. Okay, and I'm going to click my mouse and I'm going to make these bars get 10% higher. Do you see that? So here you can see the first bar is 2, now it's 2.2, 2.2. Now look at the last bar, it's 10.11. When I click the mouse and make it 10% higher, it's 11.12. What a coincidence, it's the same height as the red last bar. Okay, so now I'm going to do the trick. I'm going to move the blue triangle. Instead of all the way to the left, I'm going to put it all the way to the right. If I put it all the way to the right and I click the mouse and make it get 10% higher, It covers exactly the red triangle behind it. And now what's left over? Now the only thing left over is the first bar, the first red bar. And I drew a picture here to represent that. So I took the blue shape, I multiplied it by 1.1 to make it 10% higher. It covers exactly the right side of the red shape, and there's only the left bar on the red shape that's showing now. Okay? Now, let's go to the right. Okay, so I am going to start with an expression which is obviously true, which is that the sum of the first 19 terms is equal to the sum of the first 19 terms. Okay? Basically what I'm saying is the red triangle shape is equal to the red triangular shape. That's true, right? Okay, everybody believes that. Now, I'm going to break down the S19 expression, which is the red triangular shape. I'm going to break it down into two ways. The left side, what I'm going to do is I'm going to say, okay, the red triangular shape is equal to the blue triangular shape plus the last bar of the red triangular shape. So I'm saying S18, which is the blue triangle shape, plus 11.12, which is the last bar, is S19, right? And then the right side, I'm going to break it down differently. I'm going to say that the blue triangular shape times 1.1, okay, the blue triangular shape times 1.1, which makes it 10% higher, covers up the right side of the red shape. What's left over is the first bar of the red shape, which is 2, right? That's how much he ran on the first day. So, the sum of the distance he ran on 18 days plus how much he ran on the 19th day is equal to the sum of the 19th day. And the sum of what he ran on the first 18 days times 10% plus the first day is also equal to S19. So you can break these expressions down into variables, and it looks like this. Okay, you can see that the 2 is actually U1, 11.12 is actually U19, right? And then we can make U19 equal to U1 times R18, which is from the expression for the term for geometric sequences. Okay? And then the rest of it stays the same. And then I'm just going to do a little bit of factoring here. And when I factor out the R here, and I factor out the U1 here, then what I'm going to end up with is a fraction here where S18 is equal to this expression, r to the 18th minus 1 to the u to the 1. Now the r here, of course, was 1.1 in the problem that we did. So now I can use this formula to calculate the sum of the first 18 terms. I put in 1.1 for r, I put in 2 for u1, I put in 18 for n, and then I multiply it out and I get about 91 or something. That's how far he ran on the first 18 days. Okay, I'm sorry that was a little bit rushed.